Hello everyone, my name is Lucas Victor, and today I'll talk about parser combinators. First, we need to understand what is a parser. What is parsing? Parsing is a process that analyzes data. Usually, these data are strings, and transforms it into other structured data. This process usually follows a set of rules defined by a formal grammar, which describes how the input structure and how the input syntax must be. So a parser can be viewed as a function that receives an initial data, and if this data follows the rules defined in the parser, it will generate a final data. And if not, it will generate an error. Parsers are used in many different contexts in computer science. It is used to create language interpreters, for checking texts, for checking programs' outputs, and in compilers, a parser is responsible for checking if the source code follows the language syntax rules and generating an intermediate representation of the source code. This representation usually is an abstract syntax tree representation. An example of this is when we create a simple function and we want to compile it, one of the steps in the compilation process passes this code and generates a structured data like this one. It is a tree representation that has all information about the source code, and it will be used in the next steps in the compilation process. So about parser combinators, the main idea of a parser combinator is to combine simple parsers to create a more complex parser, combining multiple parsers into a single one that executes all the parsing processes. So instead of writing a complex and sophisticated parser, we can write simple and small parsers and then use a parser combinator to generate the final parser. Basically, a parser is a function that receives parsers and returns a single parser. As you can see, the idea behind parser combinators is pretty simple. William Burgess started working with recursive parsers in the 70s, but something more like a parser combinator appeared only in 1989 in a paper by Richard Frost and John Montgomery. They used functions to combine parsers to create a natural language interpreter, and this interpreter answered questions about the solar system. And they did it by creating a dictionary and simulating the English grammar rules, setting these rules by combining the parsers. And the functions that they used to combine parser in this work are very similar to the parser combinators we have today. Today, I'll use a library called Parsec to demonstrate how parser combinators works. So Parsec is a library for written and combining parsers. The original Parsec is a Haskell library, where we have Parsec clones in other languages like Java, Python, and JavaScript. And I'll use a Python version today. To install the library, you just need to use pip install parsec, and it will be able to be used. You can create a simple parser using the function string. You just need to indicate the string that you want to pass. In this case, we pass in the string hello. So if we try to parser the string hello world, it will return the hello found. Now we have two string parsers. We have a hello parser and a world parser. The Parsec library gives us some tools to combine these parsers. We can use the addition operator, and the output of the resultant parser will be an union of each parser output. But if we try to run this in that string, we'll see an error because there is a white space that we're not passing yet. We don't create a parser to consume this white space. A way to solve it is creating a space parser. And to do this, I'm using the function rejects. This function allows us to create parser from any regular expression. So here I'm passing a sequence of white spaces. And by combining the space parser with the string parsers, Using the skip operator, we indicate that any white space character after a string must be ignored. And now we can run the string hello world without problems. We can also combine these passes using the compose operator. Like the skip operator, it will discard the values produced by the first passer. In this case, it will discard the values produced by the hello passer. So if we pass the string hello world, only world will be returned because the hello passer was ignored. Now that we know the basics of Parsec, let's see a more complex example. This example is from the GitHub repository of the library, and there you can see the complete implementation. I'll let the link on the description. We want to build a parser that solves a math expression. And to do this, we need to create parsers that accept all the symbols expected in math expressions. So we need a number parser, and we need to create a base number parser to parse the positive numbers, and a negative number parser to parse the negative numbers. And here I'm using the function parsec map to combine a parser with a function. And at line 4, I'm using the OR operator to combine a parser using the OR logic. After that, we need parsers for the operators too. So we have a parser for the additions, for the subtractions, multiplications, and divisions. To resolve the operations, we need to create auxiliary functions. So we need a function to resolve additions and subtractions, and a function to resolve multiplications and divisions. After that, we just need to combine these parsers. First, we need to parser a number, and after a number, we pass an operator and other number. And to do this, I'm using the function setBy. SetBy passes a sequence of occurrences of a parser, ignoring the separator. So here I'm passing an operator and a number, ignoring all the spaces between these characters. And the result of this parser mode will be a number with a list of pairs with an operator and another number. And at line 5, we define the order of the operations by combining the mood parser with a setBy for the additions and subtractions. And using our auxiliary functions, we resolve these operations. And now we have a final parser that can resolve simple math expressions like this one. And that's it. In this video, we saw an introduction to Parser combinators and an introduction to Parsec. All the references used for this video will be on the description. Thanks for watching and see you soon.